Hi guys, welcome to Hutsons-Hacks. Today I'm excited to announce a new package has made its way onto CRAN, one that I've published. This package is called OddsPlotty. This is something that I developed when I worked in research, in healthcare. We used a lot of logistic regression models and we wanted a way to visualize those logistic regression models more effectively in terms of the variable effects on the thing we were trying to predict. So I'm going to show you the implementation of how I've developed it in CARET and TidyModels in R. So let's jump into R and let's get going with this. Okay. So I'm just going to get rid of everything in my window. So, and I'm going to say hello as well. Hi. And I'll bring everything up in my window. So first of all, to load OddsPlotty, it's the same as you would load any R package. So let me just get rid of these. Same as you'd load any other R package. But if you know you never used R before and you want to know how to install it, I'd probably say that in the visual installer at the bottom, there's files, plots, and packages. You go to install there. OddsPlotty will be pulled straight down from CRAN, and then you'll be able to use it. I'm going to load it into my library, and I'm also going to open the help. So I've got OddsPlotty in the help window, so I can show you how we can use it as going through. So this vignette more or less replicates what's in here with a couple of additions. So this package was first kind of developed to work with the CARET package. But I'm going to show you how you can work with CARET's GLM objects and TidyModels objects. So we're going to load in the library MLBench. So MLBench is a machine learning benchmarking and datasets package that has common datasets in there because we're going to be working with the cancer dataset today. So we're going to try and estimate the probability of cancer over not, dependent on the variables that we've got in our dataset, as a classification task. Again, I'm using this from a statistical approach, but you could easily break this down into a training test or a k-fold cross-validation pipeline in terms of machine learning. Please review my classification modeling in TidyModels to see how you can do that as a separate YouTube tutorial. I'm going to load in CARET, I'm going to load in Tibble. We're going to bring ggplot2, we're going to bring the OddsPlotty package, although I've already loaded that in. We're going to use E1071 and ggthemes because we're going to add some themes to our custom plots later on. So let me just collapse that down a little bit, get our environment ready. So what I'm going to bring in is the breast cancer data from package MLBench. I'm going to get rid of null values, so essentially just filtering out complete cases, so only want complete cases. I'm going to look at the head of the breast. I'm going to specify the class as a factor because ML models need this as a factor, so benign or malignant can be classified. Hit play on that. As you can see, my data frames returned there. You've got these variables which we'll go into later on, and we've got the thickness as well. Again, you can pull up help for the cancer data set as well if you want to see what all these variables actually mean. And then the next thing to do is I want to code up my variables as characters, as numeric, sorry. So they all then set to numeric. Again, you could use per or sapply or some other method to do that. I weirdly like to do for loops. So yeah, I'll probably be told off by Hadley Wickham or someone like that. So what we're going to do now is we've got our data in. We've got this breast data with cell thickness, cell size, cell shape, modular adhesion, size, bare nuclei, chromatin, normal nuclei, mitosis, and the class of whether it's got cancer or not. So we're going to use our past data labels, making it a supervised machine learning task. We're going to use our past data labels to then predict, is it benign or malignant, if we were doing it from a machine learning perspective. Here I'm just going to assess the significance, so I'm just doing this from an evaluation point of view, so more statistical inference. So training the GLM using carets. So we're going to bring in, we've already brought in the CARET library. We're going to specify the GLM model, so Train is a CARET object, so it should be CARET if you want to do the full paths. CARET train. We're going to use our class. So if you remember from the data set, class is whether it's benign or malignant. Data is equal to the breast data, whatever I called that. Method is a generalized linear model, so a logistic regression model. And again, refer to online literature around logistic regression, how it's then transformed from a linear regression to a logistic regression through a logic link function, and how that then helps classify through a sigmoidal curve. Again, I won't go into the statistics in depth. This is more meant to show you how you can use the visualizations that are produced from OddsPlotty. And it's binomial because it's a binomial classification. We've got just a classification of whether it's benign or malignant. So you need a multinomial if you want to do more than one prediction on Y. So here I've got this summary of our GLM model. And actually, as you can see, there's still a lot of variables that we've not captured. The intercept's very highly significant, which means actually out of all the independent variables we've captured, there's still lots more that are missing, which could better explain whether someone gets cancer or not. But the significant variables here are cell thickness, marginal adhesion, bare nuclei, chromatin, and this normal nuclei. Here at the moment, we've just got the raw probabilities. What we're going to do is convert these raw probabilities into something called an odds ratio. And Josh Stammer's got a really great website on StatQuest around how you work with log odds and odds ratios. So I'd actually direct you to that website. It's how you work each one of these out. Again, here it's more around working with that data. And I said earlier, the sigmoidal curve, this is essentially the sigmoidal function, this link function that helps you classify. So it's 1 divided by 1 plus the exponent of exponent times minus the z statistic, and it gives you this score here. So this is your z axis, your z axis there. And this is your bias estimate, so sum of w prime I, x, j, sub j, plus the bias. So the bias estimate would be there. Again, it's not a stats class, but that's essentially how the sigmoidal function works in terms of the logic link function and turning a linear classifier into a classification. So from regression to classification. And that's essentially what the aim of it is. Anyway, back on task. So we've got this data set, we've got the cell thickness, marginal adhesion, like I said. Other information around the AIC, if I was comparing multiple logistic regression models looking for difference in the variables that we include, then this would be the statistic that we use to monitor our models, so to compare our models. So the lower the Akaki information criterion, the better. Again, I struggle to say that one. So yeah, we've got all this data here, and we know the significant variables, essentially it. So where OddsPlotty comes in then. So OddsPlotty is a way that we can visualize these variables. So what I'm going to do is I'm going to use the odds plot. I'm going to specify my GLM model. That's the one that I've fitted. It could be my model, my test model, my logistic regression model, whatever. The important list item to expose here is the final model attribute. You'll find it somewhere in there. So it'll be down here, I would think. There's your resamples. So there's a final model within that list item anyway. So we need to bring back all those statistics from that final model. So there'll essentially be this data table here. So the coefficients and the independent variable, the raw odds, the standard error of those odds, the z value and the probabilities. And then obviously the significance based off those probabilities. So yeah, the final model, title odds plot. So I'm going to give it a custom title and I'm going to add a subtitle as well. And then from that plotty objects, I'm going to expose there's two objects in that list item. There's odds data and odds plot. I'm going to expose the odds plot. So here, what this is showing me is that it is actually linked to the significance here. So for every change, so every one change, you've got a 1.76% chance in terms of the cell thickness of having cancer. So essentially that's saying for every change in 1 unit, you've got 1.76 odds in terms of a ratio of getting cancer. So the more this increases, the more likely your odds are of having cancer. So say that increases by 10, this is going to go up by 10 times 1.76. So around about, it'll be about 14 odds of cancer there, dependent on each patient. And again, someone called me out on my stats there. So yeah, the cell thickness is essentially significant because these error bars aren't deviating outside of this cutoff line here. So actually, if you're outside of this cutoff line, you're starting to indicate that there's no effect. And the width of these error bars also indicates that actually there's a lot of variance within that independent variable. So actually from the lower estimate, it could be outside of the significance. The higher estimate, we're not bothered about that. It's more of the lower region here in case it breaches outside of this one cutoff line. So the odds of 1 are just, it's essentially saying no effect. Again, we've got one here, which is significant chromatin, the bare nuclei, modular adhesion. Normal nuclei is a borderline one. I'd be a bit careful with that, and it also comes out. It also kind of correlates with what we're seeing in the data table here. It's only just significant there, but it is a significant variable, so that can be taken into account. So what I tended to do when I was creating these plots, I'd put these in my publications, normally with data labels, and I'll show you how to do that in a second, alongside the results in a data table as well. So we've got these coefficient results, and we want a way to visualize that, because that's nice for a statistician. They understand what that means. So the z value, it's sampling the probabilities from that z-score, which is a normal distribution, which is a Gaussian. Take the z value from the x-axis. There's a standard error in terms of how much error there is in terms of raw odds. We then want to visualize that in terms of odds ratios as well. And again, the odds plot function also returns the data that underpins this as well. So we've got this nice visual, but say we want to just get the odds data. So we want to get the odds ratio. So this is a conversion. So essentially, it's just simply the exponential of the actual raw result. So the raw estimate, which will be the probability, to formulate the odds ratio. And again, look at Josh Starmer's nice, interesting tutorial of making stats fun on StatQuest. A bit of a plug there, Josh. So plotty odds data. You can see that actually now we've got these lower and upper confidence intervals. They're based on a 95% confidence interval. And you can see that actually we've got some that are lower than the no effect kind of cut off of 1. So this cell size in terms of the odd ratio is not really great. The thickness is really highly significant. It's the most contributory. It's the most important factor in terms of that, in terms of the odd, alongside mitosis. But the trouble with mitosis is the lower estimate and the high estimate, there's so much of a range between those two. It indicates there's so much variance around the mean that perhaps we can't trust that estimation. So whereas mitosis has got that quite a big odds ratio, you also need to interpret it in terms of where it falls on this chart. And as you can see, the lower estimate and the high estimate are huge. So we're given it's basically saying it's got an odds ratio of, where's the mitosis one? 1.71, say. But actually, it could range anywhere between 1, so no effect, 1.71, and 3. So there's so much variance in there that it's hard to trust that estimate. And these two can be used alongside each other to do that kind of discovery and inference as well. So yeah, we've got the odds data that supports that. And then from the back of this, what you could do is simply take the fit estimates. So take these as a data frame, so just the estimates from the list item, and combine them. So you could actually just merge the data tables together. Okay, so what we're going to do now is I'm going to use different themes with those parameters. So I'm going to pass in the OddsPlotty package again, and I'm going to use GG themes this time, which is essentially a package that's been created to create themes around different plots, so different looks and fields. So I'm going to pass in my final model again, so the final model, which is the important list item from the CARET model. I'm going to give it a title, a subtitle, a point color, so in a hexadecimal code, an error bar color, we're going to give it black, point size, error bar width, and the line style. I'm going to specify the odds plot element, and I'm going to save that in another intermediary variable called plot. And then from this plot, I'm going to add a GG themes style, theme economist, and I'm going to set the legend position off as well. And then finally, with that plot object, I'm going to add a textual label to it, which is essentially, bear with me on this one. So if I go back to my plotty object, I've got plotty, I've got odds plot, and then under odds plot, I've got data. So under the list items, odds plot, under that list item, sub list item, I've got data, and under that sub list item, I've got the odds ratio. Okay, so essentially four hierarchies that are being stored in terms of data that I can access. So the way to go down the list is just to keep using these notations, these dollar signs, to expose the individual elements of the list. I'm going to round that odds ratio down to 2 digits. I'm going to do a little slight horizontal adjustment and a vertical justification as well. So if I run all that code, what I'm going to get is this nice, and again, you could also perhaps play with the color here. So color equals red if you wanted to. You know, you can play with additional items. Blue might look quite nice against that. Whatever. You could take the original point color, couldn't you, and actually make the label the same. That I don't like that. It needs to be a bit darker, navy. Okay. So yeah, then you've got the actual odds ratios on there as well. And you can add you could add more text to it. You could perhaps add another lower and upper bar, but it starts to become a little bit cut and a little bit busy. There's already a lot of information on that plot to take in anyway, around your cutoff limit, so the effect in terms of your odds ratio, the variables, the error bars, the high and low, the actual estimate in terms of the mean estimate there, in terms of the odds ratio. But yeah, it allows you then just to add a little bit more contextual information to that odds plot. Again, let's just do it again, and I won't go through each one of the options. If you need help on it, you can go to the help for the specific function itself, and there's the vignette as well. So what I'm going to do is I'm going to set it to the Edward Tuff theme as well. Okay, so now say I'm a bit more modern than some of our old machine learning practitioners. I've used CARET for quite a long time, and I'm still it's still my go-to machine learning package in R. It's a bit like the scikit-learn in Python. If I'm going to model in Python, it'll be scikit-learn that I always go to. Here it's normally CARET, but I am changing my ways. TidyModels is the future. Max Kuhn tells me so on Twitter, so let's go. Okay. So training the model with a logistic regression object from TidyModels. So I'm going to bring in TidyModels. I'm going to use fitted logistic regression, so that's what I'm going to call it. So the actual command is logistic_reg, and that's from the parsnip package, if you really wanted to have full naming conventions. I'm going to pipe through And obviously, because it's in the tidy way, they prefer you to write everything in pipes. So from Magritta, I'm going to pipe through. I'm going to set my engine to a generalized linear model, which is the family of models that logistic regression falls into, among others. I'm going to set the mode to classification, because it's a classification task that we're doing. And then the fits. So can you remember our class is whether they've got cancer or not? I'm going to fit it on all the other independent variables. So going back to our data again, just to reinforce this, we've got our y thing we're predicting, our dependent variable, and then we've got independent variables x1, x2, x3, x4, x5, x6, x7, x8, x9. So they're all going to be utilized in our equation to create our logistic regression. So that then creates the fit object for TidyModels. So you can see now I've got this fitted logistic regression model. So the important part here, and I can't emphasize this enough, the difference between this and CARET is to work with OddsPlotty, CARET, you'll use the final model list item. With TidyModels, it's the fit object that we're going to use. And I put that in the vignette as well. So say now I'm going to do the same visualizations with OddsPlotty as I did before. So this time I'm going to create a tidy odds plot. So because it's based off TidyModels, I'm going to use OddsPlotty, and I'm full naming here. You could just call it OddsPlot if you wanted to. And I'm going to use the fitted logistic regression, so the model that I've fitted previously here. I'm going to expose the fit object from that list item. I'm going to call it a unique name, TidyModels OddsPlot. I'm going to specify the point color and the horizontal line color as well. And then I'm going to add a new theme to it as well. I'm going to use this GG themes theme WSJ. And I'm going to take the legend off. And I'm also going to plot the odds data. So because this uses the same underlying, let me just go back to the model itself, generalized linear model engine based off the underlying stats package, all the results and the outputs should be the same. We're just approaching it a different way in terms of training it from TidyModels compared to CARET. But ultimately, if anyone asks you, is CARET or TidyModels better? I'd say they're actually both using the same underlying engines, but Tidy for Tidyverse people is probably easier to understand. So TidyModels are easier to understand. For your base R users and people that have been doing it quite a long time, CARET's still probably really good. The thing I like about CARET, and this is something that Max Kuhn will admit to, TidyModels has got around about 40, 50 models, whereas CARET's got 193 different variants of machine learning models that you can apply, which Max Kuhn is catching up on and developing, but still you've got that much more variety in terms of models. However, with that variety comes how do I make a decision on which model to use. So there's pros and cons of either, but I don't think either are going away for any time to come. So we've got this, so we'll create this odds plot and this theme WSJ, and you've got the same underlying data that's come through and the same options in terms of the modeling. If I wanted to just adapt these themes, I can just go here and GG themes. Let's have a look at a few more while we're online. So look, theme base, what's that? So we've got this theme base here. I can try theme, say Excel new, what's that? So a new Excel type to make it look like your Excel users. Theme, let's see what else there is. 538, which is Nate Silver's blog. Theme foundation. I don't like that one. Oh, bad. Google Docs. That's pretty nice. Actually, I like that one. I'm going to keep that one actually. Thanks guys for letting me find that one out. So Google Docs, yeah, so we've got this theme of Google Docs that we can then utilize. So essentially that is what OddsPlotty is. It was developed, like I said, when I was doing some research, but it's a way that you can really visualize the results of this perhaps statistically heavy output here, there. Statistically heavy output in terms of the deviance residuals, the overall where things lie in terms of probabilities, how well your model fits, and you can also use something called the McFadden's R-squared to actually say how well your independent variables are at, how good your independent variables are at predicting whether you've got cancer or not. Yeah, so please refer to the vignette if you've got any, if you get stuck anywhere. I'm on Twitter if you've got any questions around how to utilize the package. If there's any issues you find, submit a pull request to the supporting GitHub, which I will find in a second. So yeah, if there's any issues, then go to the GitHub site. So there's a GitHub site there. So StatsGary, that's my handle. If there's any, like say, issues, just go to a new pull request and submit a pull request there. And it will show you which version of CRAN it's on. So OddsPlotty is now on CRAN. It's got the vignettes there. How you install the package, how you use the package, and I'm going to amend this as well to show some of the examples that we've utilized today. So thanks guys, keep watching. In the future I hope to make lots more machine learning tutorials alongside some other cool stuff as well. So yeah, stay safe guys, and please subscribe.